Hello and welcome to today's lecture. Today we're looking at single-phase induction motors. Having done the operations of three-phase induction motors and understanding their principles, and so you understand to say that these motors actually work using single-phase supply. And in as much as they're using single-phase supply, they also operate using the principle of electromagnetic induction. And so a single-phase induction motor has actually a starter with two windings, okay? On the stator, meaning that we are having the main winding and also the auxiliary winding. And also in the rotor, which actually typically is of squirrel cage, of which this rotor actually spins when an AC current passes through the windings. From the word itself, rotor, meaning that there is a concept of rotation. The main advantage of a single-phase induction motor is that they can be used where three-phase power is not available. As we are aware that not all places may have three-phase, and also besides that, the advantage is that we are able to use where we do not have much need of power, okay, in an event where we are able to use three-phase that has a lot of power. And so for residential users, we can be able to use these single phases because we understand that the service cables are actually in residential areas are rare to find the three-phase. And also, on the other hand, when a single-phase motors are used, they'll be limited in relatively low horsepower and low torque load requirement applications, where single-phase induction motors are large per horsepower. And actually, there's a concept of drawing more current to generate the same horsepower. And so to present in this concept, we have unbalanced load to the electrical distribution system. And so it is important to understand that there is that complication that happens compared to three-phase also. So basically, when we look at the single-phase induction motors, they are classified under the auxiliary means that we use for starting. And so in our series, we are going to look at the split-phase motor or the resistance start induction motor. We are going to look at the capacitor start induction motor. We're also going to look at the capacitor start, capacitor run induction motor, or we can call it a two-value capacitor motor. We can also equally, in this concept, going to look at the permanent split capacitor, or rather the single value capacitor. And we are also going to look at the shaded pole motor. And so looking at the construction is that the main and the auxiliary windings actually create a magnetic field, and in some designs, a capacitor or other device is used with the auxiliary winding to create the necessary phase difference for the motor to start. Since we must understand that there should be that phase difference, right? And so as single-phase motors are not inherently self-starting. And so since I had made mention to say that we have a stator and a rotor, so for the stator, we have the core. And so the stator is actually the stationary part to understand of the motor, and its features have a laminated iron core. And the laminations rather are thin sheath of silicon steel that reduce hysteresis and eddy current losses. Since we understand that we do experience a lot of losses in our induction motors. So the other concept of a stator is that we have windings. So the stator contains at least two windings, where I had made mention to say we have the main winding and also the auxiliary winding. The difference is that this winding for the main winding is actually connected directly to the power supply, whilst the auxiliary is known as the starting winding. So meaning it is actually arranged in a manner that it has a high resistance and inductance to facilitate the starting. So it is mainly for the starting purposes. So the starting mechanism is there actually to create a rotating magnetic field. Some form of starting mechanism is actually required because a single phase, like I had said, is not self-starting, and so a single phase supply produces only a pulsating, not a rotating magnetic field. And so capacitors, as earlier as I had alluded, that we look at these different types, is that many single phase motors use capacitors connected in series with auxiliary winding to provide a phase shift and improve starting torque, right? So, meaning that in an event where we have a defective capacitor, our motor cannot be able to start. So some motors use two capacitors, a high value starting capacitor that is later disconnected by a centrifugal switch, and a smaller running capacitor that remains in the circuit. So since I'd said there's a concept of a centrifugal switch, actually this centrifugal switch in some designs is just a switch that is used to disconnect the auxiliary windings at or starting the capacitor once the motor reaches a certain speed. Then I'd also mention to say that there are two main things, which is the rotor and the stator. So the rotor, since I said it is of a squirrel cage, the most common type of rotor for single-phase production motors is actually the squirrel cage. And the construction is that it actually consists of a cylindrical coil with slots around its periphery into which conductive bars are actually embedded and connected by rings. Okay, and so basically that is how a single phase motor looks like.